Today we're going to talk about graphing exponential decay functions. So your essential question is, how can I tell if an exponential function shows growth or decay? So the definition of exponential decay is when you have an equation in the form y equals a times b to the x power, and b is less than 1. So if b is less than 1, this value right here, if that number that's attached to the x as the exponent is less than 1, then it's going to show exponential decay. And we learned in the last section that if b is greater than 1, then it's going to show exponential growth. So we're going to look at a few different examples. And we're going to tell if the following equations represent an exponential growth or decay. So if we look at this equation and we compare it to our original equation, y equals a times b to the x power, b in this case would equal 2/3, and so that is less than 1. So this one is going to show exponential decay. Now if we look at letter b, the one that is attached to the exponent is 4/3, and 4/3 is greater than 1 because that would be equal to 1 1/3. So this one is going to show exponential growth. So just because it's a fraction, don't automatically assume that it's decay. You have to pay attention to if it's greater than 1 or less than 1. Okay, this one we have 0.3 to the x power. So in this case, b equals 0.3, which is less than 1. So this one would show exponential decay. So I think you guys kind of get the general idea. Now when we're graphing an exponential decay function, this is the same as graphing an exponential growth function. Really the only way to do it is to plug in numbers for x and plot the points. Now they want us to state the domain and range. And when we're graphing exponential functions, they kind of make that banana shape, and they always flatten out at a certain point called the asymptote. So first what we're going to do is look for the asymptote. Now you can tell what the asymptote is just by looking at the equation. So if we look at this equation, it says -2 right here. So that's how we tell what our asymptote is, because this indicates that this is going to shift down 2. And so since it goes down 2, normally these functions flatten out at 0, but because it goes down 2, it's actually going to flatten out at y equals -2. So I'm just going to plug in numbers for x. So I'm going to plug in from -2 to +2 just to get a good look at the graph. You want to plug in negative and positive numbers. So if I plug these in, and you can just do this in the calculator, I would have y equals 3 times 1/2 to the -2 plus 1 power minus 2. Now when you put this in the calculator, you have to make sure that anything that's in the exponent is in parentheses. Otherwise you can just figure that part out in your head. So -2 plus 1 would be -1. So you could also just do 3 parentheses 1/2 parentheses raised to the -1st power and then subtract 2. So if we do that, -2 to the 1st power is -2 plus 1 would be -1. 1/2 to the -1st power would be +2. 2 times 3 would be 6, and 6 minus 2 would be 4. So I'm just going to make a chart really quick. Okay, then if I change this to -1, then -1 plus 1 is 0, and we know that anything to the 0 power equals 1. So 1 times 3 would be 3. 3 minus 2 would be 1. Then if I plug in 0 right here, then 0 plus 1 is 1. 1/2 to the 1st power would be 1/2. 3 times 1/2 would be 1.5. And 1.5 minus 2 would be -1/2. Then if I plug in 1, then 1 plus 1 would be 2. 1/2 to the second power would be 1/4. And then 3 times that would be 3/4. And then if I take 3/4, oops, oh my goodness. Sorry, my pen was not wanting to write. If I take 3/4 minus 2, then I get -1 1/4, or -1.25. You can do decimals or fractions, it really doesn't matter. Then if I plug in 2 plus 1 would be 3. 1/2 to the third power would be 1/8. So then we would get 3/8. So 3/8 minus 2 would be -1.625. Now make sure you're plugging these into the calculator and getting these same results. So you might want to pause the video, put this in the calculator, and make sure that you're doing it right. Otherwise you might make a mistake on the test that you don't want to make. So, whoops. There we go. We're going to plot these points. So we have -2, 4. -1, 1, 0, -1/2, 1, -1.25, and 2, -1.625. So you can see it's going to keep getting closer and closer to y equals -2, but it's never actually going to touch that. And something you might do at the beginning is draw a dotted line where your asymptote is. That way you know where the graph flattens out, so you won't go past it when you're plotting your points. You can keep plugging in numbers. If we plugged in 3, 4, 5, 6, it would keep getting closer and closer to -2 but never get there. So you would kind of start to see that the more points that you plugged in. So if you're not sure where the asymptote is, you can just keep plugging in more numbers and see where it flattens out. Okay? One last thing, the exponential decay model is the same as the exponential growth model. The only difference is that we have 1 minus r instead of 1 plus r. So remember, a is the initial amount, r is the rate, and it's always expressed as a decimal. So if it's a percentage, you'll need to change it to a decimal. And t is the time in years. So if we look at this question about snowmobiles, it says a new snowmobile costs $4,200. So the value of the snowmobile decreases by 10% each year. That kind of stinks, because then if you want to resell it, it doesn't really have a lot of value. So it says write an exponential decay model giving the snowmobile's value y in dollars after t years. So first we're just going to plug in our numbers. So basically we know that a, the initial amount, is $4,200. We also know that the rate is 10%, which would be 0.1 as a decimal, or you can put 0.10. And then we don't know what t is because it says after t years. So if we write our equation, it would be y equals 4,200 for a times 1 minus 0.1 for r to the t power. Now you should probably go ahead and simplify that. So if we have 4,200 times 1 minus 0.1 would be 0.9 to the t power. That would be our simplified equation. Okay, now the next part says estimate the value after 3 years. So we're just going to do that by plugging in 3 for t. So then it becomes y equals 4,200 times 0.9 to the third power. Now remember, if we follow the order of operations, we have to do exponents first. So do not try to take 4,200 times 0.9. You can't do that. You have to do exponents first. So we're going to take 0.9 and raise it to the third power, and then we're going to multiply that by 4,200. So the answer should be y equals $3,061.80 if you did that correctly. So make sure to double check this in your calculator and make sure you're entering everything right. You can also just, if you have a scientific calculator, you can go ahead and just put this in exactly like it is. As long as you use the parentheses, your calculator should follow the order of operations. All right, make sure you guys go back and answer the essential question and write your summary. Thank you.